There are two different types of sequences. There's arithmetic and then there's geometric. A sequence is just a pattern of numbers. An arithmetic sequence can be found by adding or subtracting a common number. So if I have 1, 5, 9, 13, dot, 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 we can see here going from 1 to 5, we're adding 4. 5 to 9, adding 4. 9 to 13, adding 4. This right here is what we call our common difference. And that's because we are adding or subtracting the same number. Okay? There are two different types of ways that you can write an arithmetic sequence. It depends on whether you want to know like the 100th term and how you what information you have in order to find that. We have what is known as an explicit formula for this. With an explicit, you do not need to know the previous term. You need to know the first term, the number of terms, and the common difference. Okay, so what this means is if I were to ask you right now, okay, what is the 100th term based on that sequence above? I could plug in my information and calculate it without having to go through and write out, okay, 13 plus 4, plus 4, plus 4, and go through all of those different numbers until I got to the 100th term. I could actually write it out. With what we've got here, we would have AN just represents the last term or whatever term you're needing. A1 is going to be the first term plus n minus 1, and our D value here is 4. Notice I put that in parentheses because if I have a negative number, if you write it without the parentheses, it looks like you're just subtracting 4. Okay. So anyway, I could substitute in 100 and get my answer. Then we have what is known as a recursive. A recursive formula needs the previous term. So if I want the 100th term, if I don't have 99, I can't go anywhere. Okay. So with a recursive formula, I still have my AN. I have A1 for n equals 1, and then I have AN minus 1 plus D. And that's for anything greater than 1, because our 1, the n equals 1, represents the first term. N just represents term number. That might be something you want to note. Okay. So I could use my previous term, which is represented here, and add my common difference. Now, there's another type of sequence that we need to look at. If we're dealing with plus or minusing a common number, our geometric sequence is going to deal with multiplying or dividing by the same number. If I have 1, negative 3, positive 9, negative 27, dot, dot, dot. Okay, if I'm looking here, I can see I am multiplying by negative 3 each time. Okay, so common ratio. Okay, that ratio, some people get a little confused by this. That ratio is found by taking G2 over G1. Notice I split it up into terminologies. Geometrics is everything's with a G. Arithmetic is with an A. Kind of makes sense, right? So then we have an explicit for this, and we also have a recursive for this one. So for the explicit, if I have G sub n, this is going to be G1 times R to the power of n minus 1. Again, n represents the number of terms. The recursive, G1 for n equals 1, Gn minus 1, so the previous term, times R, for anything greater than 1. So again, you're just plugging in the information you have. Based on this information, I'm going to ask you different things, you know, like if I have start with a sequence and then I give you some number here at the end, let's say it's, I'm just making some number up here, 343, how many terms are there? You're going to be manipulating these formulas in order to figure out what you need based on them. So you're going to have to use some algebra. And at this point in time, I feel like you guys should be able to do that on your own. Okay. There's also something that we need to talk about in terms of our sequences. This is going to be a little bit of coming back from prior knowledge. We have limits of our sequences if it's an infinite sequence. Infinite sequence means it goes on forever and ever, obviously infinite. So we can't necessarily find the ending. We might be able to find the ending point, or we might not. If it converges, that means that as you go on forever, it goes towards a certain number. So as you go towards infinity, it will be a finite number. Finite meaning ending. It diverges as you go towards infinity. It keeps going on forever. So it'll either go to infinity or be non-existent. Okay, talking about limits. Realistically, we've done limits before, but now we're dealing with it in terms of a sequence. Okay. If I were to have 2n plus 1 over n squared. Okay, realistically, we're talking about as the limit approaches infinity of our function here. What is it? That's what we're realistically doing. This is limit notation. It's just been a while since we've done it. Because we have a function and we have division and we're going towards infinity, we can use that end behavior of simplifying. I don't know if you guys remember this, probably thinking I'm crazy right now, but that's okay. We're just going to look at the highest degree of the numerator and the highest degree of the denominator. Canceling out that plus 1, it's junk. Okay, it doesn't mean anything. That tells us where we're going to go. So if I have the limit now of n going towards infinity of 2n over n squared. Okay, I'm going to simplify this. This realistically goes to 2 over n, right? Because I can cancel out an n. All right. So they tell me, fish. Okay. Well, graphically, you could figure out as the limit is going towards infinity of 2 over n, it's going towards 0. You could also test this out if you didn't know how to do this algebraically. Okay, there are some of you thinking, fish, you're nuts. I'm not sure I could do this on my own. Here's what you could do. I could plug in my numbers and kind of see a pattern here. Okay, so if I plug in 1, first term, if I plug it in, I get 3. So now I'm going to plug in my second term and see what happens. Well, I get 1.25. Let's plug in 3, see what happens when we go there. Okay, 0.77. Okay, I can see here it's getting smaller and smaller and smaller, but I might, because I have an explicit formula, I might just jump to, okay, let's plug in 100, see what happens, right? Well, this goes down to 0.0201. Okay, well, I'm seeing this pattern here. It's going towards 0. Okay, so if all else fails and you don't remember how to cancel that stuff out with the limit notation, you could always substitute numbers in and see what's happening based on the numbers. Where's it going? Okay, so I can see going from the 3 to 1.25 to 0.777, you know, onward that it's going to 0. So this function specifically, we look at it here, it's going towards a finite number, so it's going to be converging. Okay, and then we would state it converges to 0. Okay, so that's based on our sequences. Actually most of this should be review. Arithmetic sequences, again, you're adding or subtracting a common number. Geometric sequences, you're multiplying or dividing by a common ratio or a common number. And then we're looking at our limits of sequences.